Hello. So let's start. You don't have to write tests. Yeah. I've actually heard that there's a $1 trillion company out there making phones mostly, and they rely heavily on army of manual testers, almost no automated tests. And the last time I checked, they were doing pretty fine. You don't have to eat vegetables. Yeah. You know, internet is full of stories of people who haven't eaten a single carrot in their life, and they are still happy living their lives, and they're healthy. You don't have to go to gym. Actually, in 1800, doing sport was considered uncivilized and practiced only by the lower class. But maybe, it's easier if you go to gym, because maybe your job is sitting by the computer all day, and going to gym actually helps you with your back pain. Maybe it's easier if you eat vegetables, because maybe you're not one of the lucky few who can get their vitamins out of the thin air, and maybe it will make you more healthy. And maybe you're like me, and you work in an environment where writing tests makes your life easier. My name is Vojta, and last year I started a company called Industrial Binaries. And we are a team of iOS developers, and we specialize in fixing technical debt for our clients. So what I do most of the day is refactoring and cleaning up someone else's code. Voluntarily. And for refactoring, having automated tests is crucial, especially when you need to keep everything functional during the refactoring process. Because while we work on the cleanups and on the refactorings, the clients still can develop new features and reuse the app. So the app has to be releasable at all the time. That's why when Apple announced SwiftUI and Combine last year at .up, of course I was excited, like almost everyone else. But then immediately, my second thought was, how are you gonna test this? So I tried to find out. I created a simple weather app. It takes your current location, goes to the Open Weather API, and shows you the weather. It has 2 buttons, so you can identify whether you like the weather or not. And I built it using Swift and UIKit. And this app is fully covered by tests. I also made the designs, as you can see. And then I took this app and I refactored it to use Combine and SwiftUI. The design is still the same because that's the point of refactoring. It changes only on the inside. And in this talk, I would like to share with you how did the refactoring go, and mainly, how did it affect the overall testability of the app. I chose the community's favorite MEVM pattern for the app, and I wanted the implementation to be as straightforward, as mainstream as possible. I really tried hard not to be clever at all. I'll share the link to GitHub repo with both versions in the end, so you can then tell me if I managed not to be clever. I'm gonna walk you through the parts, and I'll start with the location provider. I always choose the most interesting test case to show you. So the implementation in Swift looks something like this. Basically, location provider is just a wrapper around CL location manager. It has one output, and that's an observable of a state. When state is an enum with 3 cases, either we're loading the location, we have the location, or there's an error. And the test for this is also quite simple. we use RxTest. That's the reactive extension. It's the test extension for RxSwift. And it looks something like this. First, we have to take the test scheduler. I'm going to talk about it later. We're not using it that much in this case. And we create something called testable observer. It's a thing that when you attach it to an observable, it records everything that's happened in the observable. So then we take the output from the location provider and attach the testable observable. We simulate the system callback. So we just call the delegate of the location manager with some mock location. And finally, we just assert that we received the events we expected. So it was the loading event, which is the default one, and then that's there's a new event for the test location. Quite straightforward. How does it look in Combine? The implementation is basically all the same. The only difference is that the output is now any publisher. And here you can see, really, it's the same amount of lines. I think the Combine version is like 2 lines longer or something like that. And I think this is amazing. It's really great that Apple didn't try to reinvent the wheel with Combine. They are using the established patterns in the Rx community. So really, the refactoring from Rx Swift to Combine, or even from reactive Swift to Combine, is almost like one-to-one. You just change the names. So we have the production code refactored. So we can go now to the Combine's documentation to find out how to test this. So let's go to the website. Let's search for tests. Perfect, we have one match. And it's the test flight lane. So unfortunately, Apple doesn't tell us how to test this. But we have a great example in RxTest. So we can just build something like that ourselves. Let's call it a recorder. And it's a subscriber that records all the values from the subscribe publisher. When we initialize it, we can give it either the number of records we want to record, or just leave it as the default value of nil, which means that it will keep recording until the publisher completes. Then we have the rest of the API, which is one call called wait and collect records, which, surprise, pauses the test execution and waits until all the records are recorded, and returns an array of records, while a record can be either a new value or the completion signal, completion value. Finally, we can create an extension of a publisher that will just help us to create new recorders by calling record. And yeah, that's it. So the whole recorder, it looks like this. It's not that much. It was like a project for 2-3 hours without any prior knowledge of Combine. It was pretty straightforward. It's mostly about formatting. And this is how we use it in tests. So we create a new recorder from the output from the provider. We simulate the system callback. We wait for all the records. And then we assert the recorded values. That was easy. So yeah, surprisingly easy. We can then move on to the next part, which is the weather API. And the test case I want to show you is that the weather API was successful, the weather data was successfully fetched from the API. The implementation in RxSwift, this is basically a copy-paste example from the website. These are the lines of code you want to show to someone when you want to convince them to use RxSwift. So it's just a function that takes coordinates and returns an observable of weather, which is the model struct. And then we use the existing extension on URL session. We create a data request. We decode it. And then from the decoded data, we create the model object. For test, for mocking, I'm using custom URL protocol implementation. It's, I think, the most convenient way how to mock network responses. It basically, you can hook up to the system URL loading mechanism, and you can just say that, hey, for this URL, I don't want you to go to the network, I will handle it locally. So here we're saying that for the endpoint URL, we want to just return some sample response. And I have an article about mocking network calls with URL protocols on my blog. There'll be a link in the end of the presentation. Then we create the weather call, and we use this Rx blocking syntax, which is just a shorthand for, this basically stops the execution of the test and waits for the result to come. We have some expected results, and we just assert that the result we get is the result we have. In Combine, it looks basically the same. So Apple also provides extension on URL data session, the URL session. It's called Data Task Publisher. We decode it, we map it, amazing. The only difference is that in the end, we have to call arrays to any publisher. It's because of the way Combine works with its types. Because if you have a publisher of integers, for example, and you map it to a publisher of strings, the resulting type isn't publisher of strings, but the resulting type is mapped publisher of strings of integers, and it's getting crazy. So in the end, you have to type erase it using this operator. And the test looks very similar. The tests look very similar too. We're just using the recorder we created earlier. So it was so easy, it's almost boring, right? But don't worry, don't worry. The next one is the view model. And the test case I'm going to show you is that when the view model receives the new location, it fires the network request succeeds, and the view model emits a new output. In Rx Swift, we define the view model as a protocol, view model type, because we want to be able to mock it later. Its inputs are the inputs for the buttons, so these are the subjects. We can then bind the buttons to. So there's one for the like button and one for the dislike button. And it has one output, which is a driver of something called weather view model state. And weather view model state, it's just an enum, again with a loading state, with some loaded data, and or with the error. And now the test. Yeah, it looks a little bit more complicated. We're using the test scheduler here. And scheduler in Rx Swift is something that actually takes care of performing the actions scheduled by the Rx Swift in the right order and at the right time. So Rx Swift tells it what to do, and scheduler performs it. This test scheduler is special because it doesn't use the real time, but it uses something called virtual time, and it's just an integer. And it does nothing until you call resume on it. And when you call resume, it performs all the scheduled actions immediately and synchronously. You'll see how we use it. So we create something called test observable for location, and we tell it to, at the time 0, emit the value of loading, and at the time 100, emit a value of type location with some mock location. Then we do a similar thing for the API, where we want to simulate that the API request was successful. So at the time 100, we want to return a successful value with some mock data. Then we create a view model, and we start observing the output from the view model, which is the state. Finally, we can start the scheduler and assert that we have the right data and the right events. So we have one event at the time 0, which is the loading. That's the default one. And then at the time 200, we have a value of loaded mock, which is what we wanted. And the time is 200 because the first 100 is there from the location, and then the next 100 is there from the API. In Combine, the view model looks a little bit differently because we want to use what the system provides us, or the Combine provides us. So we use this observable object, and we use this property wrapper published. It means that any changes to the state will be then easily propagated to anyone who observes this observable object. And then again, we have two inputs for like button and for the dislike button. The implementation is, again, almost the same, and it was really one-to-one transition. It was super, super easy. And here you can see that the tests also look the same, which is amazing. And they look the same because these are the bits that I had to write and were missing there. So I had to create my own test scheduler for Combine. I had to create my own test publisher, and then some custom assertion overload to just assert that the values are correct. And while the recorder was a nice task for 2 hours, this was like a weekend project, so this wasn't like trivial at all. So the view model, okay, it looks good, but it was a lot of work. But yeah, that's why we're here, right? And finally, the view. And I would like to show you all the test cases for the view. So with Rx Swift and UIKit, the implementation looks like this. It's the most straightforward implementation of bindings. I just basically take the output from the V model and update all the UI elements, and then I just take the buttons and bind them back to the V model. And folks, I want it to be so mainstream, I even use storyboards for the UI. Yep. So let's test this. Because our view model is defined as a protocol, we can easily mock it, so we can create something like mock view model with the outputs and inputs, and then use it in test. So we create a mock view model, we set its state to loading, and then we set the view model to the view controller. We need to set the animation speed to 0 because loading state has a spinner, and we want it to be in the defined state. And then, because we're testing UI, we're using snapshot testing. And I'm using the snapshot testing library from the Point3 guys here. So we just run it, and bam, we have a very nice screenshot. Let's test how the UI looks when we have some data. So we assign the data, bam, and yeah, we have a nice screenshot. And well, if this doesn't make you smile, how nice and beautiful and easy it is, then come on. The last test I want to show you is the test when we test that the like button is properly binded to the view model. So it means that if you tap on a button, the view model gets the action. We create a mock view model, assign it to view controller, and then we call load view if needed. This loads the view, which causes the view.load method be called, and it sets up our bindings. Then we start observing the actions on the mock view model for the like button and dislike button. And because I use storyboards, I have access to my outlet. So I can just take the like button and send it action directly, like if it was tapped. And then I can just assert that the events in the like stream was, their count is 1, and in dislike it was 0. So basically the the like stream received an event. Combine and SwiftUI. This wasn't one-to-one transition because to properly mock view model while using SwiftUI, we have to do something differently. So if we say that our view model is a protocol that just extends observable object, so we can then use it like this in the UI. If we try to do this, we get this error. And who has seen this error before? Yeah, it's everyone's favorite error. So what it's telling us is that we should use view model type as a generic constraint. So it basically tells us to do this. So we should make our view generic over its view model type. And this might sound like a good idea, but it's not. You don't want your views to be generic over your view model type because then it spreads like a disease, and suddenly you realize that your whole app is generic over your mock data and view models, and it's crazy. You don't want to do that. So we have to be a little bit clever here, and we have to try something different. And we can remember the good old Objective-C days, because this is how we used to do mutable objects. So I make this property file private, and then I subclass the view model. Yes, I made a subclass. And in this subclass, I just expose the setter for the state. And I can do it because it's in the same file, so I can set it from within the file, and nobody from the outside can mutate the view model, so, which is what we want. But now, everyone can use our test view model in the production code. That's not what we want. So we have to do something about that. So either we can just do something like this if you run your test only with the debug configuration, or if you need to run your test also in the release configuration, you can create some custom flag specific for your scheme, which you use in the test. So it means that this test view model will be accessible only from your test, not from your production code. All right. So we can now make the tests with our test view model. We assign it, we create our new view with the view model. We set the state to loading, and we have to wrap it into the host controller. We call assert snapshot, and bam, we have snapshot. Let's do the same with the loaded data. Perfect. Okay, now the last piece, and that's the button tap. We want to test that if I tap on the button, the view model gets the action. So yeah, you know the drill. Let's go to the documentation of SwiftUI, and let's search what Apple tells us about it. One match. Yeah. Okay. And this is sad. This is really sad. Because in SwiftUI, we don't have access to the views that are rendered on the screen. We don't even know whether it's views or how it's being rendered. And that's by design. That's how it should be. That's how we are supposed to use SwiftUI. We shouldn't care about how it's rendered. We should care only about how we describe the views. However, it means that we are not allowed to test things like this. So there is unfortunately no way how we can test this. Or is there? You know, before Apple started shipping their UI testing framework in Xcode, XC UI test, we still did UI testing. And we used this framework. It was called GIF. And this framework is still being maintained, so we can still use it. What GIF is, it's a test framework that runs in your unit test target. And it uses some clever Objective-C runtime magic and a lot of reverse engineering to basically convince the simulator that there's a user tapping on the screen. So I prepared several classes from Conf, did some changes, wrap it in a nice SwiftUI, Swift API, and we can now use it in the test. So it looks like this. We can just call simulate interaction, and then we can just tell it to tap on the element with a specific accessibility identifier. It's an ugly hack. You're not supposed to do this. It uses undocumented API, but this is the only way how I made this test work. So yes, technically, this is also green because we didn't lose any testability there. However, we had to use some dark magic there, so I'm going to give it a dark green color. All right, let's wrap up. The results. RX Swift to Combine. I think it was perfect. Really, the refactoring of the production code was amazing. It was surprisingly easy. Unfortunately, we had to write a lot of test helpers for that. And it makes me a little bit sad because the helpers, it wasn't difficult to build them, but I'm sad that Apple didn't release them, because it would have been such a nice and strong statement from them that they want people to test their code, to show them that it's easy to test code with Combine, and that they take testing seriously. So I think it was a missed opportunity from them, because they must have these extensions there. They must use it, because you can't build a framework like Combine without unit testing. So they exist. They just don't want to release them yet. UIKit to SwiftUI. This is more difficult. I think SwiftUI, if you want to use the MEVM architecture, it's dream come true, because it just works out of the box. You get all the changes, all the updates, all the bindings, everything's for free. It's amazing, really. If you want to test the declarative part of SwiftUI, how the UI is laid out, how it looks like, and you can use snapshot testing for that, it's great too. It's the part where this declarative world meets the imperative world when you needed to trigger some actions or do something different. That's basically what's currently untestable. So I'm not sure how to approach this. I think the benefits of having less code, of not having to care about the bindings and about the updates, they're really good, because less code means less bugs. So I would also give it a checkbox, but a small one. All right, and the final slide with all the links. You can follow me on Twitter. I will post the slides there, so you can then click the links directly. You don't have to type it to your phones. The links there. There's a GitHub repo with both versions of the weather app, the RX Swift and UIKit, and the Combine and SwiftUI version. There's also a link to Combine test extensions. These are the test extensions I wrote during the refactoring process. There's a link about the article about the mocking of the URL calls. And there's also a nice library called Entwine, and it's basically a one-to-one re-implementation of RX test for Swift. It looks really, really good. I haven't tried it, but it looks that the person who writes it knows what they're doing. And finally, there's the GIF testing framework. And yeah, that's all I have for you. And thank you. This is nice one. How do you test view model? The beauty of it is that you don't have to test it. Let me go back. Come on. This one. Yeah. You don't need to test this because there's nothing to test. Because the driver, publish subjects, they are tested within the RX test framework, within the RX Swift framework, and then there's nothing else. And when you change the view model state, you directly modify these elements. So there's no logic. It's really just a mock, and you can directly modify the things within the mock. All right, thank you.